Let's have a look at what we already know. This is a fairly fraught area because frequently it comes to you as, well, you've got to do a literature review. And it, it, it's seldom expressed as, look, go and find out what we already know about this problem, because what we already know could be what the industry knows that's published in trade magazines, not academic literature, and quite possibly is not as rigorously demonstrated as academic literature might be. Nevertheless, that can be the best source of information, particularly in leading edge software problems or leading edge computing, which does tend to lead academia quite a bit. So now the reason why we do this is that new knowledge, like new software, is expensive. It takes time to develop, and when we get there, there's no proof that we're right. So it's about as reliable or as unreliable as new software. It takes time to test it and to debug that knowledge. So it's better if we can find existing knowledge that we can use. The quality of the knowledge is measured by how true it's likely to be. Now, it can be proven reasonably true by repeated use and found that it in fact works, or it can be found to be true by critical reasoning and the burden, the amount of evidence to support it. So you really are better to find out what's already known, and with so much knowledge now, that is not that hard. All right? Then we determine what we don't know that stops us making progress. Now the question comes, what knowledge ought we pursue? Because there's so much knowledge available, it's very tempting to say, right, well, you want to know stuff, I have no idea what I'm looking for, but I'll grab all the stuff and dump it all, and there it is. It's an impressive 10 pages or 20 pages of literature review. Well, that's not useful. The information you're looking for should relate to the problem that you're trying to investigate. All right? It really ought to be relevant to the problem. Well, let's look at that. Usually, what we're looking for are the elements of the problem, their attributes, and the relationships among them. Now that might sound simple. I've come across that in architecture, software architecture, where you're talking about the elements, the structural elements of the problem, the relationships among them, and the attributes of the elements. So it seems to be pretty much the same thing with knowledge. When you've got a problem, what are the elements of that problem? What are the attributes of that elements, and what are the relationships among them? Now there's an example, we talk about modeling the problem, which is a reasonable way of doing it. There's an example there which happens to be the technology acceptance model, which was proposed by Ben Bassett, I think. And I've seen that model being repeated a number of times, and it's a fairly simple, straightforward model, so it's a good example to use. So most problems do have a number of elements, but not all of them are relevant. Right? So, most things do have a number of attributes and or a number of elements, but some are relevant in some circumstances, but not in others. So you've got to find out which ones are relevant to this problem. Now, of those elements, what are their attributes? Are they an element of size? So you measure it on size, or the element of social construct? You measure it by some sort of a social estimation, psychological scale, or something like that. What is that? What are the attributes? And what are the relationships among them that are likely to be important? Now the problem elements, sometimes they're already known and sometimes they're not. Part of your investigation might be to try and determine what the elements are in the first place. And this gets into, say, case studies or ethnography, where you're trying to examine the world and determine what it is or what matters in that world. So frequently the task could be to determine what the problem elements are. And there, I caution you, the elements of interest are frequently context dependent. Now the relationships between the elements, if you're interested, the picture there is the elements of Hofstede's cultural dimensions. The relationships among them, sometimes it's a hypothesized relationship, and we're trying to determine whether that relationship is true or not. Or we know there's a relationship, we're trying to determine the magnitude of it and the direction of it. Sometimes this is done statistically through linear regression, and sometimes it's done through factor analysis. But if you're trying to determine these elements and their relationships, then you can have some fun to try and sort out just what the relationships between the elements are. So the attributes, we might know the elements of interest, but what are their attributes? And we want to characterize or quantify the attributes. And by characterize, I'm talking about categories such as color or what are we talking about? In some cases in software, we're talking about the type of machine or the type of operating system, or the type of something. They're categories. There's no sequence, there's no ordering, there's no relationship among the categories. They're simply categories. There are quantifiable attributes. These are things that you can measure: cost, perceived value, size, quality. Quality breaks down, but quality decomposes into a number of other attributes. But these are things that we can measure. Take the technology refresh example. The attributes of interest with the cost and the risk. Now we have the cost of refreshing, that is the retraining costs and the actual upgrade costs. The cost of not refreshing, which gives some measure to the risks, so the disruption costs and the risks of incurring them if something crashes, and the support costs and the risks of incurring them. Right? So if something crashes, there has to be some support. What's the probability of a crash, and what's the probability of cost of fixing that crash? What is left unknown? What remains unknown is what prevents progress in this problem. Okay, so you've had a look at the problem. You've got the elements, you've got their attributes, you've got the relationships among them. What is it you don't know? Why can't you just now go off and solve the problem? What remains that will contribute to a useful solution?